Welcome to another video and welcome to this tutorial. Uh, in this tutorial, we're going to be looking very deep into the second part of set theory, which is set builder, because we must know how to build a set. So if you are given a questions, that is why we need to know the concept of inequality symbol before we can do anything. And the first thing is we have greater than, so we have this less than, it face the right hand side, so greater face the left hand side. Why for the greater than or equals to? So we have greater than and we put equality sign under it. For the less than or equals to, so we do the same thing. And these four powerful symbol, we'll be using them very well to build a set. Let's see examples. Let's say interpret or list out the elements of the following set. And so the purpose of this set building, introduction of this less than, greater than, other stuff. So it's very, very important. So don't underestimate it. Let's see the first example. Um, the question says, we should build a set. And here we have X such that these uh, two dots are like a colon is known as such that in mathematics. That is, we are given the value of x such that minus 2 less than or equals to x less than or equals to 2. So that is the value of x, it take on some values. That is just like a ranges between -2 and 10. But how can we know all the value of x within these ranges? All right, if I have the first one, which is minus 2 less than or equals to x, the real interpretation of it is x greater than or equals to minus 2. And while the second one so remain the same as x less than or equals to 10. And the combination of these two results into this, because in a given set like this, you cannot write both in opposite inequality symbol, so it will create a confusions. So both of them must face the same side, and the one I circle is the real interpretation of it. But after you combine them in a set, so both of them will be facing the left hand side. If you want to use left hand side full, or if you want to use the right hand side, I mean the greater than or less than. And to do this, so it means that minus 2 will be the first one. And why do we choose this minus 2? I will explain later. So then what follows is minus 1, then we have 0, uh, we have 1, we have 2, 3, 4, and that's how it will be going till it reach 10. So the reason why this starts from -2 and end at 10 is because of equals to that was added. I repeat, equals to that was added. That is why it starts from -2 and it ends at 10. So that is the value of x itself can still be -2 and the value of x can still be 10. So that is the essence of it. And let's check this number line. If I have this as 0, all the left hand side will be minus, negative, negative, negative. So while the right hand side will be all positive throughout. So from this question we are given, that is the value of x itself is -2 because of the equality signs, and it keeps going like that till it reach 10. Because of equality sign we put 10 there. And let's see the second example. We have 3 less than or equals to y less than 15. And so what differentiates the first and the second equation is, so the first one is having equality, the second one does not have equality sign. How can we interpret it? So it means that the y itself can also be 3, and the y can be what? 4, the y can be 5, and that's how it will keep going till it reach, can you guess? Till it reach 14. So I will stop at 14 because y less than 15. All right. So all the ranges of y, those are the elements we just list now, but it doesn't reach 15 because y less than 15 itself, that is y stop at 14. And let's say the third example. So we have m such that -7 less than m less than -1. And so this one throughout, it doesn't have anything like equality sign, but both of them are negative. So let's see how to present this on a number line to know all the values we are going to be list out. So know all these sides are positive, while all these this is negative and the side is negative. This side is 0 and the other side is negative. And we're going to have negative throughout: -1, -2, -3, -4, -5, 6, -7, -8, and as many as we want. But here is a -7 less than m. That is, the value of that m is greater than 7. And we know that when we want to determine the negative, so if it is positive, positive will be going up, but negative will be reading it downward because of that negative. That is, the smallest will be the highest. I think that is clear. The smallest will be the highest, and the highest will be the smallest. So that is why this starts from -6 and others that I listed. All right. So m less than -1. That is, -6 is greater than -7. -5 is greater than -6. -4 is greater than -5, and others like that. And here is another typical examples. So from here, -2 is greater than -3. That I've said earlier that the big number will be the smallest, while the small number will be the biggest number. That is for the case of negative. That rule, it doesn't concern the positive. So no 2 greater than 1, 3 greater than 2, 4 greater than 3, and others like that. But for the case of negative, the highest will be the smallest, while the big number will be the small, and while the small will be the big. So that's just this. And let's see another example here. Here we have -1 less than a less than or equals to 12. So here we are starting with from 0, from that number line, that is -1 less than a, that is a starts from 0 dot 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 to 12. So why do we stop at 12? Because of this equality sign, that is a can still be 12 or a can be less than 12 as others number that we have. Let's see the this example E. So I've been using less than throughout. Yes. So this can still be greater than, but remember it must be uniform, not that one will be greater than, one will be less than. If you want to use greater than throughout, you use greater than throughout, and if you want to use less than throughout, you use less than throughout. So here we have 2 greater than x, or we have x less than 2. These two, they have the same meaning. Either we have 2 greater than x or x less than 2. While for this one, we have x greater than or greater than -1. Okay, that is, we can still have it as -1 less than x. Okay, if this less than x, so what are the value of x itself? So that is, the value of x can be 1, can be 0, can be 1, can be 2, and others like that. So now to write out all these elements, so 2 greater than x and x greater than -1. So if you take this one on a number lines, all right, suppose I draw a number line here, the middle is 0 and all these are negative, why this is -2, 0, 1, and 2. So from this we said 2 greater than x, right? And it means that the x itself is 1. X can still be 0, and x also greater than -1. That is, the two elements we are going to have here is 1 and 0, because x greater than -1 and 2 greater than x. So which means the intermediate values are going to be 1 and 0. So if this is clear enough, I think we are good to move to another stage, which is other examples. And if any stage is not clear here, you can pause the video and we'll watch it again. But I think this should be clear enough. All right, and it can also be written like this as -1 less than x and x less than 2, or you can use 2 greater than x greater than -1. Here is the last examples I'm going to the last example I'm going to do here. But looking at this, it's different from what we have been doing. So we have y squared minus 5y plus 6 equals to 0. So you might think that, okay, this is wired. How can I get all the elements of this. So it's very, very simple. What you are going to do is just take out the equations. Once you take out the equation, which is y squared minus 5y plus 6 equals to 0, and here is a quadratic equation. So because the highest power of this thing is 2, and that is why it is quadratic. All right, so the highest power is 2, that is quadratic. And what we can do here is we just try to factorize this just to get the root of all this. And the root, I mean here, they are the elements that we are looking for. So the middle term here is the sum of the root, while the constant term, which is the 6, so we call it the product of the product of the root. Now, how can we get these two things? So it's very, very simple. What we are going to do here is we are going to look for two numbers. If you add it, it will be minus 5, and if you multiply it, it's going to be plus 6. So that's why I've decided that it is minus 2 and minus 3. So minus 2 minus 3 is minus 5, and minus 2 times minus 3 equals to 6. So we are going to replace all these things in this. So suppose we have y squared. We have y squared. We just try to replace 5. Instead of 5, so we replace it with minus 2 and minus 3. That is minus 2y minus 3y. Then y this is, we are going to replace it with minus 2 times minus 3. Everything equal to 0. So this is clear. Then we are going to group this into 2. Don't forget that. So we group the first 2 and we group the last 2. So it's still 2 because here is operation multiplication. Then what is common from the first one is y is common. Then we take out y. Here is y minus 2. And if you try to expand this, we get what we have above. Then let's take out negative 3, because negative 3 is the common factor here. So taking out this negative 3, since it's common in both that we're trying to combine, so we are left with y here. And while for the second one, we are going to left with minus 2. All right, since it's minus 2, and if you multiply plus and minus, so it's still going to be negative. So we have this, everything equal to 0. If you can look at this clearly, you see that something is common. Y minus 3 is common, and we combine y minus 3. Since both of them, they appear at their coefficients, then we take 1 y minus 2. So since we have these two, we have factorized it already. And to know the root, so just say y equals to 3 and y equals to 2. Okay, so because both of them are negative, so which means that the root of these quadratic equations in the set form is 2 and 3. That's the element of the root. That is the element of the set. And here comes to the end of this video. Let's wait for the other part of this, which is the operation on set. Thanks for watching.